Good morning, everybody, and welcome to another week where we are continuing our graphing discussion, but we are close to the end. Let's see what we are talking about for 2 days. If we remember our graphing steps, just open the YouTube chat just in case someone has a question. I can see it. Perfect, thank you. Graphing steps, it's always good to remember them. You should by now. We have our warm-up step where we may find a Y-intercept, see if what kind of function I'm working with, what do I expect, if you expect anything. Just getting into the right mindset. Then we had our asymptotic behavior. Ooh, that's an ugly H. Where we analyze the function and we see what's the long-term behavior, are there any asymptotes, so on. We might not know the behavior close to the asymptotes perfectly, but when we get to increasing, decreasing behavior, that that asymptotic behavior is sort of completely figured out, and you can pick the arrows according to where it's increasing and decreasing. So I don't worry about fully answering the asymptotic behavior of the graph close to the asymptotes. I just want to know if there are asymptotes. What's the long-term behavior, and so on. So for step 3, we analyze the derivative, see where's the function going up, where's the function going down, critical points, and so on. Then we looked at concavity, analyzing the second derivative. How is the graph bending? Where is it bending up? Where is it bending down? And so on. Now, if you have all this information, or if you're given this information, either way, there is a fifth step where I want to put all of it together and graph the function. And that's something that's easily overlooked and not given enough attention to in books, really all the books I've seen. They don't just isolate this last step, that regardless of where the information comes from, I figured it all out by doing all these steps, or it's just given. Can I put everything together and see what the graph looks like? Can I put all the pieces of the puzzle together? That's not that easy. So I want to devote some time to just that step because uh, there is a midterm question exactly like this. But it's also very important to be able to put the pieces together and see what the puzzle looks like. So I don't really know. We're just going to go through some problems. Actually, let me do it on a new page. Go, go through some problems, see if there are any questions, see if there's interesting things I can see in preparation for a midterm question, if nothing else. So let's just look at whoopsie, eraser mode randomly. Problem 9.4. We're looking at, well, I might as well just do number 1. So I'll just show you what it looks like, but I'll copy the information. So it's at the very bottom of page 60 where the problem number starts. So determine a rough graph of the function with the following information. Sometimes they give you all the information you need. Sometimes they leave some stuff out in terms of specific y values so that you can focus on the shape and you can pick a y value that gives you a nice curve, and we'll see that as we go. So we have some information here. Let's zoom in a little bit more. Oh, that's too much. About the function, about its long-term behavior, about some derivatives, some second derivative values, and then the most important parts of the table. And we'll duplicate this. And I suggest that if you don't like the look of this, to maybe make it look more familiar. So I'm just going to move this off to the side, but I am looking at it. And let's copy it to maybe make it look a little bit more familiar. To see if, so let's see, can we do anything in step 1? Do they give me a Y-intercept? They give me nothing. All right, so nothing. That's nice. Great start. But step 1 was an optional step anyway. So step 2, asymptotic behavior. They tell me f of 1 is undefined. They tell me the limit. So yeah, we're wasting a little bit of time copying these over, but we have 2 days for just this. I think we're going to be okay. And maybe I want to make it look more familiar. They tell me the limit. Oops, was it negative infinity? Yeah, that's a negative infinity over here. Negative infinity is a 2. And the rest is derivative information, which is not a part of step 1. The tables that they give me, not a part of step 2, rather. Okay, so let's perhaps, what should we do here? I kind of want to put the graph up here. Why not? Pick a straight line tools. Oh, what was that? That was supposed to be a straight line. Let's put it up here and see. Okay, so this now means, now for our kinds of functions, having the function be undefined will indicate that there is potentially a vertical asymptote there. Now, in general, I know that's not necessarily the case, but we're not looking at functions that have weird things and all kinds of technicalities. When the function is undefined, it will be a vertical asymptote. I don't know how it, for this kind of question, I don't know exactly how it's going to behave close to that vertical asymptote, but I know there is one. So at this stage, maybe I'll leave my arrows as options, just like I would normally. Nothing is changing. I just don't have to do all the work. I can skip right to the graphing step. Horizontal asymptote? Yes, because these infinite limits exist. Equal to 2. Let's put 2 maybe a little higher. I don't know what's coming up, right? They don't really give me y values, so I seem to be free to choose them. So that's at 2. I don't know how it approaches that line, but I know it's on both sides. Both limits have a value of 2. Okay, so I kind of like this question because I don't have to do any of the work. They give me the answer. I just have to visualize it. It's kind of nice. So just don't get confused with these kinds of questions. If it says something's undefined, they're really saying it's a vertical asymptote, just to keep things nice and simple. Okay, so that's what I have. They don't give me a y-intercept, maybe to make the graph nice and easy to work with. Sometimes it's hard. If they tell me that's a y-intercept, sometimes you get a little wobbly trying to get through that, because you have that target point that you have to get through, and that makes your graph wrong. So they sometimes leave out some y values just to make it easy to focus on the shape of the graph more than anything else. So don't worry if you feel something's missing in terms of a specific y value. That's done on purpose. So next, and again, we have 2 days for this. Please feel free to interrupt me with questions at any stage. Then they tell me some derivative information. So they're essentially giving me the important parts of the table. There's some stuff happening that I don't see, and then I get to see the end result of the sign of the derivative. And it's broken up at 1 and at 2, and that's it. Notice that, I'll show you this again here. Notice that here, they're not giving me the full sentences. I think this is a little bit nicer, actually. 1 is not included because the function is undefined there, right? So that 1 in any sentence that you may want to write, the x equal to 1 is excluded. But that's the only one where it's undefined. 2 is a square bracket if you were to write those sentences, which you don't have to, of course. So I have a minus, and then a minus, and then a minus. So it's all minuses. Okay. I also want to know what happens at those x values, right? So that's where they give me this middle box. The derivative at 1 is undefined. The derivative at 2 is 0. So I can put that right in my table. Derivative of 1, undefined. Derivative of 2, 0. So now, this is really all I need. I have a negative slope line, then some bad stuff's happening, which I know is a vertical asymptote, then a negative slope line again. Negative slope line, 0 slope, so horizontal asymptote, and then, no, not negative. Not positive, but negative again. Okay. So different things are happening, but at the very least, let's at least refine our asymptote arrows next. So I remember everything's decreasing everywhere. So if everything is decreasing, it can't be this top arrow working left to right for the horizontal asymptote. It can't be that top arrow because then it would go up. It has to go decreasing down, decreasing to the vertical asymptote. So it can't be the top arrow of those two. That's increasing. Decreasing down from that from that vertical asymptote. Can't be the bottom one then. Decreasing down towards the horizontal asymptote. Can't be the bottom arrow. So again, let me show it on the same screen here. By waiting for step 3, increasing, decreasing behavior, the choice of arrows close to asymptotes, that choice is as easy as it can possibly be. There's no extra work needed. Whereas when I do it in step 2, or try to, it's not impossible, but it's unnecessary work when step 3 is going to give me which arrows are the correct ones anyway, as sort of a side effect. It doesn't even try to answer that question. I just get it for free. So that's why at step 2, I didn't care about having choices for arrows, knowing step 3 is going to resolve that. Okay. So now let me get a picture here. It can be tricky. I don't want to go too fast. And to be honest, I don't remember the answers for these. I have no idea. I'm doing it with you as if it's for the first time. I don't remember these at all. And some of them I've never done. So it's nice to sort of discover it together and see where are the sticky points that I need to watch out for. So I'm going downhill all the time. Though at x equal to 2, I have a 0 slope. Okay, so x equal to 2. Now they've given me the freedom to choose a y value that suits my preferences. They don't tell me the y value. So it could be anything, but not anything. It can't sit over here because then how am I going to get to my horizontal asymptote without increasing? So there are some restrictions on the y value to fit with all the other information. That point has to be somewhere over here, right? So let's just put it there temporarily. What happens there? It goes down into a horizontal tangent and then down again, which fits with everything else. So I'll just put a little line there, remembering that's a horizontal asymptote. So I'm thinking it's probably going to bend in some way, right? I don't know. I don't know. Now, because I've never done these, there might be a typo somewhere in some of them, but let's explore that together. Let us see. And then, before I get to 2 around the asymptote, it seems like I'm just going to go down somehow. But we'll see if there's a change in the bend. So right now the picture is forming. It's not too bad. Again, let me know if you have any questions as we go. Picture's not quite finished, right? I need to know step 4. So let's see what that gives us. So from that, there's a table as well. They give me the important parts of the table. Oopsie. I don't see the pieces of the function. I just see the end result. And that table is split into x equal to 1, 2, and 4. And it gets a minus, a plus, a minus, a plus. Then I also want to know what happens to this second derivative on those x values. They tell me 1 is undefined, 2 and 4 are both 0. All right. 1 is undefined, 2 and 4 are both 0. So it definitely helps me to make it look more familiar, to put those zeros and crosses and stuff on it, even though it's not in the question. It's separate in the question, making this table look a little less familiar. Put it on top. Put it on those lines, like I'm used to doing. Okay. So that means I'm bending down, up, down, up. Okay. I'm going to zoom out. How do I zoom out? Ooh, that's a good question. Nope, that's not what I wanted to do. How do I zoom out? I lost my shortcuts on my drawing pad. Now I don't know how to zoom. How hard can it be to zoom? You'd think... No, that's not it. Get away from me. Ah. You'd think there'd be a zoom button, right? Am I just not seeing it? Well, is it this one? Yeah, that helps. Okay, good. Okay, so it's hard to move a little up and down, but so up to x equal to 1, I'm concave down. I'm bending down, which is what I thought. It fits with how I'm supposed to behave close to the asymptote. So I can fill in that piece and be done with the left side. And it seems like the right side, of course, I didn't leave a lot of space. The right side has more interesting things. Whoa, why that wobble? Why? I'm going to blame my hardware because, of course, it's never me. I'm never at fault. I don't make mistakes. There we go. So at least that part is done. Now there are some more interesting things happening here. And of course, I left not a lot of space to do that. So let's see if I can zoom in. So what's happening here? Well, something's happening at 4 as well. Let's put 4 over here. And let's just clean up the space. I didn't look ahead, so I didn't leave a lot of space for myself. But let's just work with what we got here. So I know something's happening at 2 and something's happening at 4. Let's just put them randomly like that. They have to go downwards to the horizontal asymptote. How much space you give yourself? No, who cares about that? Now I have to remember these things are in different spaces. I'm going to have to move up and down, so I have to remember 1 to 2. I'm bending up, then down, then up. Up, down, up. So I'm coming from high up. Whoopsie. Of course, horizontal asymptote here. Asymptote. Horizontal tangent at x equal to 2. So maybe right to left drawing is a little easier. Then I'm going to bend down. Why? Let's try it this way. Whee! Oh, sound effects help. I see. That's not a vertical tangent or anything. It just has a random angled slope, but it changes in the bend to up again. Like that. There we go. That's not so bad. I just didn't give myself a lot of space. Unfortunately, I didn't know. Where the given space here is a little bit better, right? Some better spacing. All right. That wasn't bad at all. How do we feel about that? I know, stunned silence. Yes. This one, don't underestimate it. It needs some practice. It needs more practice than some people think. So let us not that one. Let's do another one. See what we get. Let's go to, why am I writing so big? That's better. Problem 9.4. Let's just do the next one. Number 2. Why not? I don't know which ones are good and bad. They're just questions. Now I have the graph spacing at the next page, so I just need to focus on that. All right, so let's see. So many people, they struggle because they want to know what kind of function is it. They want to see the function. It's a little bit of a challenge in its own to not have that luxury to analyze the function, to see the function. I just have to use this information. And that's all I have. So let's see. Warm-up step, yeah, there's a little bit. I can have a Y-intercept because they tell me f of 0 is -3. So this one gives me some function values. It also gives me some x values, x-intercepts. But I'll remember that for later. I'll just write them down so I don't forget them. Then I get to step 2, asymptotic behavior. They give me some limits. Far to the right, -infinity. Far to the left, -infinity. All right. So no horizontal asymptotes. Nothing's undefined. So no vertical asymptotes. Okay, that's all good news. This makes my life easier. Or more difficult, I don't know. Maybe you like asymptotes, but I have none of them in this case. So let's see what step 3 gives me. So I did the first 2 boxes. Give me some points. Long-term behavior. No asymptotes. Nothing. So I'm sort of thinking, this might be some sort of polynomial, right? I don't know what it is. They saved me that trouble, thankfully. But I'm thinking maybe some polynomial. Doesn't have any asymptotic features. So now I'm in the increasing decreasing behavior step. and I need to see that table. So I like to copy the table, make it look more familiar. So let's do that. There's my number line. They don't show me the detail, but they tell me I need to split this up into, according to -3, 1, and 4. All right. So I get a plus, a minus, a plus, a minus. Just copying it over. Then they tell me that the first derivative at -3 is 0, at 1 is 0, and at 4 is 0. That seems very polynomial-like to me. No asymptotes, just horizontal tangent lines. So I have a positive slope, horizontal tangent, negative slope. Negative slope, horizontal tangent, positive slope, positive, horizontal, negative. All right, that seems pretty easy. Do they give me any y values? Yeah, they give me this one is y equals 0, this one y equals 0. They don't tell me what happens at 1. Maybe for convenience of graphing it. Who knows? All right, so that's what we have. So we have a lot. We didn't have that much from step 2, so I didn't bother graphing it, but maybe now, definitely let's graph it. Hopefully I'm giving myself enough space in the areas where it matters. Who knows? So I'm going far to the left and far to the right down for both. That came out of step 2. I have a y-intercept at -3. Let's just put it randomly over here. I don't know. We might have to adjust it. If I need more space there, I can move it down. I have an x-intercept, -3 and 4. That's not super, this is important, but super important. Luckily, it lines up with where the critical points are. -3, 1, and 4. Okay, so let's give me some space here. Let's say -3 is over there. I know that's an x-intercept anyway. 1, maybe a little closer. And 4, maybe over there. And that's an x-intercept as well. I don't know what the y value is at x equal to 1. Okay, so the step 3 information tells me that I'm making a little crest as I pass through -3. At 1, don't know. I'm making a little cup, which if I'm going to go down through this y-intercept, it's going to have to sit below it. So I'm going to put that point somewhere over here. And remember what happens there. Then at 4, we're making a little crest again. That does fit with the long-term behavior that I got out of step 2, that they're both going down, far to the left and right. So everything seems good so far. I'm increasing from 1 to 4, decreasing down, increasing all the way to -3. Everything seems to work. So far, so good. All right. Now I just need step 4 to tell me how this guy bends. And luckily I have some space. Squeeze it in. So I'm looking at the question. That's where I'm getting all this, of course. Second derivative. I need to split it up at -1 and 3. That's a 3. Why are these lines so long? I don't need them to be that long. Alrighty. Then I have a negative, a positive, a negative. And they tell me that second derivative values, -1 and 3, they're both 0, which for a polynomial, they would be. If the first derivative is 0 in a polynomial, the second derivative is going to be as well. And I'm thinking polynomial, definitely. So I'm concave down, concave up, concave down. Does that fit? Oh, so at -1, something interesting is happening. An inflection point is happening. Now I'm just going to temporarily put it here. It might not be a convenient position for my graphing, but we just have to have a point because they don't tell me the y value. I have the flexibility to make it convenient for my graph. So I don't struggle. If I have a specific point that they tell me, I might wobble trying to get through that point, and then it's not right anymore. It needs to all be smooth. And then a 3, oh, 3, let's put 3 over here. These are all different. Inflection point, let's put it over here. These are inflection points, and I could choose the y value. So I'm bending down through this point, then bending up to that point, then changing, bending down. So everything seems to fit. Now I just have to make the graph pretty. So let's get through to our first inflection point. Clear all the temporary stuff that I did to help me remember. I'm going to try and hit that point, but if it's very inconvenient, I'm not going to. So I know there's a horizontal tangent here, so I'm just going to go wee. Sound effects definitely help a lot. This angle is weird for me on the tablet. Can't see my hand. I'm not writing on the screen. I'm writing on my table and looking at the screen, which is weird. Try to get that line. Sometimes draw it in little bits. Still looks smooth. I'm going to take it as a success. Now, what often happens is I run into trouble when I try and hit a Y-intercept. But I can make this scale whatever I want. No one tells me what to do. I am going to just focus on my graph and then say, oh, that's -3 right there. Easy. It's not always that easy, but that's what I'm going to do. And no one can stop me. Now I have a horizontal tangent here trying to hit that inflection point. Just try and be as smooth as you can be and bend correctly. And if you need to adjust the scale a little bit to suit your needs, well, I'm labeling everything. It's totally fine. Then I have to get from here to this horizontal tangent. Drawing wise, it helps me to go from the horizontal tangent. Whether that's left to right or right to left doesn't matter. But when I speak, I always talk as if I'm going left to right, of course. And then let's hit some nice sound effects. Horizontal tangent down. Whee! Whoa, that sound effects did not help me there. Whee! Let's just stop there. Call it a day. It definitely bends down. I don't know how fast. Just whatever's comfortable. Look at that pretty graph. Zoom out a touch. That's too much. Don't zoom out that much. There we go. There we go. Not too bad at all. But it's maybe nice and relaxing to just sit back, watch me do it. This will be a question in the midterm. You have to be able to do it. Not this specific one, but this kind of question. There will be a question on step 2. There will be a separate question on step 3, separate question on step 4, separate question on step 5. And in that way, I can mix up the functions. You're not going to do the whole thing from start to finish in a test, because then if I mess something up early, everything else gets messed up too. And for a test, that's bad idea. But for practicing, it's different. So we want to be ready for this kind of question. Any thoughts so far? It might look easier than it actually is, so please do not be deceived when you sit back and watch this. It's not necessarily that easy. I'm not saying it's hard, but it's different when when you just watch something versus having to do it yourself. It's different, and you need to be aware of that. Well, all we're doing, we've done all the background stuff we need to do. Now it's just practice, practice, practice. So we'll do another one. Why not? We have the time. You came all this way. Why not? But ask your questions. That's the benefit of a live session. You can stop me at any time and ask. I don't know. I'm going to look for something different. This one looks very similar. I don't know. Maybe not. No, maybe not skip it. I can't remember. By skipping it, I might miss a nice one, so let's not. I don't know what the answers are. I'd like to not know what the answers are because then you get a more authentic experience to see where do we pause, where do we slow down, what do we watch out for, because I don't know either. All right, we have a function. We don't know what it is. Let's see what we can do. We've got some stuff. We got some Y-intercepts. Well, there's only one. Y-intercept, because they tell me function value at 0 is 0. That's the only function value they give me, which is always, for me, nice, because that means I can make my graph look pretty. I'm not restricted by a specific Y value, making it tricky sometimes to graph. Step number 2 is not that interesting. I have no asymptotes. The function, they don't say the function is undefined anywhere, so I can then assume that it doesn't happen. Oh, just one negative will be fine. So there's no vertical asymptotes. There doesn't seem to be any horizontal asymptotes either. So far pretty boring, which is why I wanted to skip it. But maybe it has something interesting to say. I don't know. Let's give it a chance. No horizontal asymptotes, no vertical asymptotes, because it's going to have to be undefined. And they don't tell me anything about that, so I'll assume then that there aren't any. So far this is pretty boring. There's nothing interesting to graph yet. I'll do these later, the negative infinities. So let's see, maybe there's something interesting coming up. I honestly don't know, which makes it fun. So step 3, increasing decreasing behavior. What do they want me to split it into? A couple of pieces, -2, 0, and 3. All right. Now you don't have to copy these, but I'm doing it anyway. I don't like writing on a PDF. It doesn't look as nice. So I get a plus, a minus, a plus, a minus. Then they also tell me, as they need to, what happens at those x values. -2, 3, and 0. So I get 0, 0, and undefined for the derivative. 0, 0, undefined. So I get rid of that line. 0, 0, undefined. So notice that we have seen this before, that the derivative can be undefined, even though the function's fine. Right? Like, for example, the fraction powers of x, that's often the case, that the derivative and the second derivative have more problematic x values than the original function did. So it can happen. No problem at all. But without that experience, those examples, I've seen people look at this like, how could this happen? The function's not undefined, but I get something here. Yeah, it can totally happen. So I get an increasing section, horizontal tangent, decreasing. decreasing, horizontal tangent increasing. Increasing, bad times, decreasing. So we'll see what that means as we now move to our graph. So let's set this up. Not like that. It's when I use my push to talk button and draw straight lines. For some reason, it doesn't like that. It doesn't like that at all. Which is why I always draw straight lines in silence. Not because I'm focusing, because I literally can't hold down my button at the same time. So, both long-term behavior limits were going down. All right. I have to go through this point. No flexibility there. It is the y-intercept at the origin. Okay. Now, interesting x values. They're all critical points, actually, right? Because the function's defined everywhere. So all these guys are critical points. So there's a point for all of them. -2, let's put -2 over here. I don't know what the y value is. Let's put a pin in that. 0, that's a critical point too, the y-intercept. And 3, let's put 3 over there. So now what is happening here? At -2, those are on the way to -2. I have to increase. I have to go up. And then turn around at -2, go down through the y-intercept. Okay, so my critical point has to be fairly high, or above the the x-axis at least. So I'm going to have a little crest there, going up towards it, then down towards my next critical point at 0, and there it's going to be a little cup. So that's okay. Then I'm going to go increasing towards my next critical point at x equal to 3. What is happening at x equal to 3? I haven't asked you any questions yet. What is happening next at x equal to 3? The first derivative, the derivative, I don't need to call it the first derivative. The derivative is undefined. But they didn't tell me the original function was undefined, which means it's defined. I can't assume stuff. So there is a point. The derivative is undefined. What is happening with the graph at x equal to 3? These are things you have to know. I wouldn't be asking them if they're not important. Any ideas? How can I have a point and a graph, yet no derivative? Curve downwards, that is a little bit vague. I'm not sure what you mean. I'm asking, there's a point up here. Let's put it right there. There's a point. How do I go through that point? What is happening? What is happening when there is a point, the function is defined, but the derivative is not? We've done this before. It is a vertical tangent line. Vertical tangent. So I'm going into it like vertically up, make a point, and then decrease down. Now exactly how, we'll see once we get the bend in the graph. So I don't really want to draw the graph now, just waiting until I see exactly how the bend is. I have a good idea, I can guess. It looks like it has to bend down, change somewhere between -2 and 0 to bending up. It can bend up right into that vertical tangent line at 3, and then we'll see what happens. We'll see what happens, but I need that information. I always have a little bit of room left for my concavity. Second derivative tells me, oh, I can't even see my question. Tells me, break it up at 0 and 5. All right, I will do that. 0, 5. And it goes minus, minus, plus. All right. I need to know what happens at these x values. The question says it's undefined and 0. Interesting. Okay. So I'm bending down, bending down, bending up. Ooh, that does not look very right, does it? I wonder if there's a typo in this guy. That does not fit with what I have, does it? No, it does not. There's a typo here. That doesn't sound right. Let's pretend this is on purpose. How can the second derivative information agree with what I have so far? There's no way. What do you think? Now, of course, I'll double check a midterm question before I give it to you. Fair enough. But a lot of these, to be perfectly honest, I've just put them in the problem book, knowing that we'll discuss them. And I get them from other books, and sometimes there are just typos in those books. And unfortunately, I don't have the time to do the solutions for all of these. I suspect that there was a typo somewhere. This doesn't match, does it? Yes, for this bit, for sure. From the first bit leading up to -2, definitely bending down, right? That is totally believable. Sure, I'm going up here, I'm bending down, like we've seen before. Horizontal tangent top, great. I can bend down to a point, but in order for me to hit this crest, this turning point at x equal to 0, I'm going downhill, horizontal tangent, uphill. It makes that little cup. Did I say crest? No, I meant cup. Little cup shape, a turning point at x equal to 0. Through 0, I have to be concave up. There's no choice. It has to be concave up. Look at the cup. The cup is bending up. It's a full bend and everything. So yeah, there's a point missing. There's something missing over here. I need to change from bending down, which I do through -2, to bending up. I have to change somewhere over there. Do you agree with that? We found a little typo in the question. See, my gut said skip this question, but it's better now that we found it and I can edit it so it's better in the future. I think that's better. Do you understand what I'm saying though? In order for the first derivative information, the increasing decreasing behavior and the crests and the cups and stuff to behave like they say they do, the bend has to change. There has to be an inflection point between a crest and a cup. There has to be. Because the functions are defined everywhere. Any questions? Any thoughts? You're very quiet. I don't like it. It's making me uncomfortable. It's unfortunate we found a typo, but at least I want to be clear because this could easily happen, right? You could actually come up with all these steps and something doesn't agree. You get this. You did step 4 yourself. You get this. It's important to see that, whoa, how can these pieces fit together? It's impossible. It's impossible. So I made a mistake. Something here is not right. It's garbage. Now I'll go and edit it and fix the problem book, but it is what it is. But I don't want that to be confusing for you, so I want you to let me know that everything is okay. Deep breaths. We're going to fix it. Actually, let's see what it should be. I shouldn't have done that, right? Let's fix it. Let's see what should it be so this all fits together. I need an inflection point over here. I must have one. There's no other way. Let's get rid of this garbage. Fix it now. And then I will edit the problem book and we will all be happy. These things happen. Sometimes it's good to see something weird that doesn't look right. The pieces of the puzzle don't agree. It's not always flowers and rainbows. What does it look like when things go wrong? Pretend I've come up with it myself. I need to spot where there's a problem. It's not always bad news. I see you don't want to talk to me anymore. I have a typo in a problem book now. We're not on speaking terms. I understand. You're not happy. I totally understand. So let's put it here at -1. Why not? I have to bend down all the way through that. Let's bend into that. Not that straight. Let's bend into that inflection point. I need to just make my cup a little bit wider so we can reach it. There we go. That's a little straight for my liking. There we go. Something like that. So I'm changing from bending down to bending up. And I'm going to bend up all the way through to this vertical tangent line. Let's just clean that up a little bit here. Like so. Get in there. Nice and vertical. Yeah, that's good enough. It's close. It's pretty good. So I'm bending up all the way through to x equal to -3. Let's suppose that's it. Let's say that's it. That is what my second derivative table looks like. That's it. Because when I leave that vertical tangent point, remember this is not a polynomial, right? Polynomials don't have these sharp points. What kind of bend is that? That is a concave up. So it's bending up throughout, even though there's this turning point allowing the graph to go down. The bend is up throughout. So we fixed the typo, right? But I don't want it to be confusing for you. So hopefully that's better. Now there's a chance that if you look at this video after the fact, I'll update the problem book and there won't be this problem anymore. So it's going to be a little confusing perhaps. I'll edit the video somehow. Don't worry about it. Okay, so I'll go and edit the problem book so that this does not happen again. But please let me know if you have any questions. Practice. Bring some questions tomorrow if you're not sure about it. Or you pick one of the problems and then we can discuss that one because there are 10 of them and we're not going to do all 10 of them. So I want it to be more of a discussion so that you're ready for anything the midterm can give you. But of course, there won't be these kinds of typos in the midterm, I hope. All right, we will continue this tomorrow with more examples. Just getting used to everything that there is to see. Until then.